Okay students, now we are discussing module 3 partial differential equations. So you have studied in earlier semester differential equations. Differential equations are those which are involving the derivatives. On the same lines, partial differential equations also, the differential equations are equations involving partial differential terms or partial derivatives. So now we can define what are those partial derivatives. Suppose we define a function z is equal to f of xy. F is a function of two variables x and y. So z will be treated as function of two independent variables. And then we are differentiating z with respect to x, that is dou z by dou x, and differentiate z with respect to y, dou z by dou y. These are the partial derivatives. An equation involving partial derivatives is known as partial differential equation. So example, x dou z by dou x plus y dou z by dou y is equal to x square plus y square. So this is known as first order partial differential equation. Why first order? Because this involves first order partial derivatives. So partial derivatives are differentiated with respect to x and y only one time. Second example, dou square z by dou x square is equal to dou z by dou y. So this is also partial differential equation of second order. Why it is second order? Because it is involving second order derivative, dou square z by dou x square. Third example, dou square z by dou x square plus dou square z by dou y square equals 0. Here 0 is missing, is equal to 0. It is second order partial differential equation. Now question is how to formulate partial differential equations. So one method is by elimination of arbitrary constant. Let f of xyz ab is equal to 0. This is a relation or a function involving variables and constants. Variables are here x, y, z, ab are constants. So z will be assumed as function of x and y. Now let us differentiate this function with respect to x once, that is dou f by dou x plus dou f by dou z into dou z by dou x is equal to 0. Again differentiate with respect to y, dou f by dou y plus dou f by dou z into dou z by dou y is equal to 0. So from the relation 1 and equation 2 and 3, let us eliminate the constant a and b, and then the resulting equation will be in the form of partial differential equation, that is represented by phi of xyz comma dou z by dou x comma dou z by dou y equals 0. So this represents a first order partial differential equation. And let us work out some examples how to formulate partial differential equations by the elimination of arbitrary constants. So example 1, form a partial differential equation by eliminating the arbitrary constants a and b from the equation 2z is equal to x square by a square plus y square by b square. That is the question. Now answer is, let us differentiate the above equation partially with respect to x and y separately. First with respect to x, 2 into dou z by dou x equals x square derivative is 2x divided by constant as it is a square plus y square derivative will be 0 because y will be treated as constant while differentiating with respect to x. So then cancellation 2 can be cancelled and cross multiply, you will get 1 by a square is equal to 1 by x dou z by dou x is equal to 1 by a square. So you call it as equation 1. Similarly with respect to y, if you differentiate, 1 by y dou z by dou y is equal to 1 by b square is equal to, that is called as equation number 2. Now use these results or values of 1 by a square 1 by b square in given equation. Then given equation can be written as 2z equals x square into 1 by x dou z by dou x plus y square into 1 by y dou z by dou y. Simplify, you will get as 2z equals x dou z by dou x plus y dou z by dou y. That is the required partial differential equation. This does not contain constant terms a and b. So this is how we can eliminate constants called ab from the given relation. So by means of partial derivative, we can find or we can formulate a partial differential equation. In second example, find the partial differential equation of all spheres x minus a whole square plus y minus b whole square plus z square is equal to c square. So here c square will be treated as the radius of the spheres. So given that x minus a whole square plus y minus b whole square plus z square is equal to c square is equation of sphere with radius c. Differentiate that equation with respect to x and y separately. So we will obtain 2 into x minus a plus 0. Why this is 0? Derivative of y minus b whole square. Y is treated as constant, b is also constant whose differentiation is 0. Plus derivative of z square, that is 2z into dou z by dou x is equal to derivative of c square is 0. So in turn we get x minus a value as minus z dou z by dou x. You call this as equation number 2. Similarly, above equation can be differentiated partially with respect to y. We will obtain y minus b value. Call this as 3. Now substitute equation 2 and 3 in given equation. It becomes minus z dou z by dou x whole square plus minus z dou z by dou y whole square plus z square is equal to c square. So on simplifying, finally we will get z square into dou z by dou x whole square plus dou z by dou y whole square plus 1 equals c square. So this is a required partial differential equation. This does not contain constant ABC where the AB where C can be present or C square can be present because this is representing a fixed constant called radius. Now in example 3, form a PDE by eliminating arbitrary constant A, B, C from the equation x square by a square plus y square by b square plus z square by c square is equal to 1. So now let us differentiate with respect to x first. It is 2x by a square plus 0 plus 2z by c square dou z by dou x. So that is differentiation of z square by c square is equal to 0. Differentiation of 1 is 0. So then you can write this as x by a square plus z by c square into dou z by dou x is equal to 0. You call this as equation 1. Again differentiating this with respect to x only, we will find 1 by a square plus 1 by c square into product rule we have to apply here, UV rule we have to apply here, z into derivative of dou z by dou x is dou square z by dou x square plus second term dou z by dou x as it is, derivative of z is dou z by dou x. So finally 1 by a square is equal to minus 1 by c square into z dou square z by dou x square plus dou z by dou x whole square. You call this as equation number 2. So we got equation 1, one time differentiation, and second time differentiation equation 2. On the same lines we can differentiate with respect to y also. Here we shall avoid with differentiating with respect to y and rewrite equation 1 and 2 in this form. So you can observe here equation 1 is written as c square by a square is equal to minus z by x dou z by dou x. Just it is cross multiplication. Shift this to right hand side and cross multiply c square to left hand side, x to right hand side. We will get c square by a square is equal to minus z by x dou z by dou x. And then equation 2 can be written as c square by a square is equal to minus z into dou square z by dou x square plus dou z by dou x whole square. And we got similar terms on left hand side of both the equations, c square by a square, c square by a square. Therefore we can equate both of them and then we will formulate an equation does not containing any constant term. So it is containing only partial derivatives and z function and x term or y term. So this is the required partial differential equation. So this is how we can formulate. Okay, in example 4, form a PDE. PDE means partial differential equation by eliminating arbitrary constant ABC from the relation z equals ax plus by plus cxy. So this is the given relation. Write it once again, and then differentiating with respect to x comma y partially, you will get dou z by dou x is equal to a plus cy, dou z by dou y is equal to b plus cx. So you call them as equation 2 and 3, and then differentiate 2 partially with respect to y. This equation 2 with respect to y. So we will get dou square z by dou y dou x, that is equal to 0 plus c into 1, that is c. So therefore c value is dou square z by dou y dou x. So we got exclusively we got here c value. This c value we can put here in place of c in equation 2 in equation 3. So then equation 2 and 3 we can write it as a is equal to dou z by dou x minus cy, that is dou z by dou y minus c value is this y into dou square z by dou y dou x. Similarly, b also we can write b equals dou z by dou y minus x into dou square z by dou y dou x. So we got ab value, and use a b c value in given relation. Then given relation can be written as put 4 5 6 in given equation. Therefore we will find z equals x into dou z by dou x minus y dou square z by dou y dou x plus y into dou z by dou y minus x into dou square z by dou y dou x plus xy dou square z by dou y dou x. On simplifying, we will find that z is equal to x dou z by dou x plus y dou z by dou y minus xy dou square z by dou y dou x. So this equation do not contain any constant abc. So therefore this is concluded as the required partial differential equation. And next method of formulation of partial differential equation is by eliminating arbitrary functions. So consider a relation containing an arbitrary function of x, y and z. By differentiating partially, we can eliminate the function. So as we did in the case of previous method called by eliminating arbitrary constant, same way we can also formulate a PDE by elimination of arbitrary functions. Example: form a partial differential equation by eliminating arbitrary function from the relation z equals y square plus 2f of 1 by x plus log y. Here f is called the arbitrary function and there are no ABC constants here. So now differentiate given relation partially with respect to x comma y. Dou z by dou x is equal to y square differentiation is 0 plus 2 into f derivative is f dash of 1 by x plus log y, and terms inside called 1 by x plus log y differentiation is minus 1 by x square plus 0. Here 0 is not mentioned, and with respect to y, dou z by dou y is equal to 2y, y square derivative is 2y plus 2 into f derivative is 2 into f dash into 1 by x plus log y, and terms inside differentiation is this 1 by x is 0, log y derivative is 1 by y with respect to y. So we can observe here there are two similar terms, 2 into f dash function, 2 into f dash function. Separate them. 2 into f dash of this term is equal to minus x square dou z by dou x from the above equation, and from this equation 2 into f dash of 1 by x plus log y is equal to y into dou z by dou y minus 2y we can write. So now these equations are having same left hand side, therefore we can compare them. On comparison, minus x square dou z by dou x is equal to y into dou z by dou y minus 2y. So simplify this, you will get 2y square equals y dou z by dou y plus x square dou z by dou y is the required partial differential equation, and this do not contain the arbitrary function f or any other constant a b c like that. In next example, form a partial differential equation by eliminating arbitrary functions phi and xi from the relation z equals x into phi of y plus y into xi x. So here phi and xi functions are the arbitrary functions. These two we have to eliminate and formulate the required partial differential equation. Now differentiate the given relation with respect to x and y. That is, we will get dou z by dou x is equal to phi y plus y into xi dash x. Differentiating xi x with respect to x is xi dash x, and now differentiating z with respect to y, dou z by dou y is equal to x as it is, phi y derivative is phi dash y plus y derivative with respect to y is 1 and xi x as it is. So from these relations we can differentiate one of the equation again with respect to x. Say I am going to differentiate second equation with respect to x. You will get dou by dou x of dou z by dou y is equal to dou square z by dou x dou y, and that equals right hand side x derivative with respect to x is 1 phi dash y as it is plus xi x differentiation with respect to x is xi dash x. So you call this as equation 2, and from equation 1 xi dash x is equal to, and it is phi dash y is equal to, these are the expressions we are getting. So then we can substitute these xi dash and phi dash values in the above equation. So we can find that above equation is what? Dou square z by dou x dou y is equal to phi dash y plus z dash x. So we have expressions here, z dash x value, phi dash y value. Substitute here in this equation and simplify or multiply throughout by xy. So you will get it as xy dou square z by dou x dou y equals, I will come to this step, equals x dou z by dou x plus y dou z by dou y minus z. Why this is minus z? It is the value of x phi y plus y xi x from the given relation. Therefore this is z value. So finally this is the required partial differential equation from the given relation called z equals x phi y plus y xi x. And in another example, form a PDE from the equation f of x plus y plus z comma x square plus y square plus z square. This is an important question or important problem to be solved. So now here you can observe in previous examples there was a relation called x square plus y square or x plus y, some plus or minus was present in two terms. Now here there is one term x plus y plus z, and here also there is another term involving x y z, and this is a relation given by arbitrary function f. This f we have to eliminate. So now first of all, before differentiation, let us assume these terms as separate functions. So therefore we shall assume u is equal to x plus y plus z and v is equal to x square plus y square plus z square. So what are u and v now? U and v are functions of x, y, z. So now put these u and v into the function. It becomes f of u comma v is equal to 0. So f becomes now function of uv and u and v are functions of x, y, z. Now that relation will be differentiated with respect to, these relations will be differentiated with respect to x and y separately. U derivative with respect to x gives 1 plus 0 plus dou z by dou x. U derivative with respect to y 1 plus dou z by dou y. Similarly, v derivative with respect to x is 2x plus 0 plus 2z into dou z by dou x. You can write in simple form 2 into x plus z dou z by dou x. Similarly, differentiation of v with respect to y is dou v by dou y 2 into y plus z into dou z by dou y. Now given relation is in the form of f of u v is equal to 0. Now this equation will be differentiated. Now this relation f of uv will be differentiated partially with respect to x and y, that is f derivative with respect to x is, it is function involving u and v. Therefore, we have to differentiate f with respect to u first and then x. That is dou f by dou u into dou u by dou x plus f derivative with respect to v into v derivative with respect to x, that is dou v by dou x is equal to 0. This is called as chain rule of differentiation. We have applied here the chain rule of differentiation in partial derivatives. And then you can substitute dou u by dou x value here, 1 plus dou z by dou x, and also you can substitute dou v by dou x here, that is 2 into x plus z dou z by dou x. So then, and further this is with respect to x. Now similarly with respect to y, this equation can be differentiated with respect to y, dou f by dou u into dou u by dou y plus dou f by dou v into dou v by dou y is equal to 0. Again substitute dou u by dou y value here and dou v by dou y value here. Simplify. Then you will get two different equations. One is equation number 3 and another is equation number 4. So these equations are involving similar terms. You can observe here dou f by dou u, dou f by dou u, and dou f by dou v, dou f by dou v. So there are two similar terms in both the equations. Now we will use determinant method to solve or to simplify. So in these cases use one determinant. So where excluding this known factor dou f by dou u and dou f by dou u is known factor, the other terms we can write 1 plus dou z by dou x here. Similarly 1 plus dou z by dou y here, and then another column it is 2 into x plus z dou z by dou x here, again 2 into y plus z dou z by dou y here, that is equal to 0. You know expansion of the determinant, expand this one, this into this, again minus this into this. So simplify here and some of the terms cancelled here, this term and this term with opposite sign cancelled, and then some common factors, that is y minus z into dou z by dou x, or from this one and this one z dou z by dou x is common, therefore it is y minus z into dou z by dou x. Similarly dou z by dou y is common, take that common term z minus x into dou z by dou y is equal to remaining terms minus x shift to right hand side plus y shifted to right hand side, it becomes x minus y. So finally, so arbitrary function f has been eliminated. So this is the required partial differential equation. And further you can practice. There are two exercise problems are there, you can practice. And then in partial differential equation we have solving partial differential equations, non-homogeneous. So non-homogeneous means any partial differential equation right hand side, if it involves x and y terms or functions of independent variables on the right hand side, that will be called as non-homogeneous partial differential equation. Okay, so now let us define partial differential equations involving only one term of partial derivatives can be solved by integrating with respect to respective variables. This is known as direct integration method. So homogeneous partial differential equation, non-homogeneous partial differential equation we are going to discuss now. Presently in this page, non-homogeneous partial differential equations. So that is that the variety of non-homogeneous partial differential equation will be involving only one partial derivative or partial derivative with respect to one variable or one partial derivative term will be present. For example, solve the partial differential equation dou square z by dou x dou y is equal to x by y subject to the conditions dou z by dou x is equal to log x when y is equal to 1 and z is equal to 0 when x is equal to 1. So here this is non-homogeneous partial differential equation involving only one term of partial derivative. You can observe it is non-homogeneous because there is function of x and y on right hand side. and it is involving only second order partial derivative, only one term. There is no other dou z by dou x or dou z by dou y. So that's why it is we can use direct integration method for these type of partial differential equations. So now write the given relation dou square z by dou x dou y is equal to x by y, integrating with respect to y on both sides. Here dou by dou y will be cancelled because we are integrating with respect to y, and then right hand side we are integrating this one with respect to y. Keep x as it is constant. 1 by y integration is log y plus some constant we have to write. That constant in generally we write c, or here we are treating x as the constant, therefore we write plus f1x. F1x is treated as a constant term or constant of integration. Now substitute the condition called dou z by dou x is equal to log x when y is equal to 1. This is given in the data. This condition is given in the data. Now substitute here dou z by dou x is log x and y is equal to 1. So x into log 1 will become 0 plus f1 as it is. So this is 0 plus f1. F1x is equal to, it is log x. So now substitute the constant value called f1x as log x into this one. So our equation becomes what? Dou z by dou x is equal to x log y plus log x. So then given problem was involving second order derivative. Now by integrating we have reduced to first order partial differential equation. Now we can integrate once again with respect to x both these sides. So integrating on dou z by dou x with respect to x is differentiation will be cancelled, only z function remains, that is z equals log y will be treated as constant because we are differentiating with respect to x. Y will be kept constant. So log y as it is, x square integration is x square by 2 plus integral of log x dx plus constant of integration is gy. Integral of log x dx is always x log x minus x, and gy is equal to constant. Substitute into this, you will get z is equal to x square by 2 log y plus x log x minus x plus gy. Okay. Now using condition z is equal to 0 when x is equal to 1. Put here z is 0 and x 1. So you will get 0 equals half log y plus 0 plus gy. Okay. My x is equal to 1, therefore this is minus 1. So gy becomes 1 minus half log y. Substitute gy value into this equation, then we will get that is z equals x square by 2 into log y plus x log x minus half log y plus 1. So this is the required solution for the given PDE called dou square z by dou x dou y is equal to x by y by direct integration method. Please understand here, whenever an equation involving only one partial derivative term, we can apply direct integration method. If it is second order, integrate twice. If it is first order, integrate only once. If it is third order, integrate thrice with respect to corresponding independent variable. And then one more example, solve dou square z by dou x square is equal to xy. Again this equation is involving only one partial derivative of second order. Right hand side is function of x and y, product xy called x into y. Therefore this is non-homogeneous PDE. With the conditions, what are conditions are dou z by dou x is equal to log of 1 plus y when x is equal to 1, and z is equal to 0 when x is equal to 0. Okay. Now given relation write once again as it is, integrating twice with respect to x, it follows that dou z by dou x becomes x square by 2 into y plus f1y. So f1y is constant of integration. So using condition, this condition, we will find the equation in terms of log of 1 plus y plus is equal to half y plus f1y. So f1y value is this. So f1y value will be log of 1 plus y minus half y. Substitute this value in place of f1y. It becomes dou z by dou x equals x square by 2 into y plus log of 1 plus y minus half y. So again, this there is a partial derivative term. Again we integrate with respect to x only. Then z equals x square derivative is x cube by 3. X cube by 3 into 2 becomes 6 into y plus log of 1 plus y. Log of 1 plus y is constant, right, as it is. So 1 remains here, integral of 1 is x minus half y as it is constant. Integral of 1 will be x, you have to write, plus constant of integration is f2y. So now in this one, use the given condition z equals 0 when x is equal to 0. Put z equals 0 here, x is 0, x is 0, x is 0, f2y. So f2y value will be 0. So solution is, final solution is becoming z equals x cube by 6 into y plus x log 1 plus y minus half xy. This is the required solution of the given partial differential equation, that too non-homogeneous. In next example, it is dou square z by dou x dou t is equal to e raised to minus t cos x. We have to solve this equation. It is a second order non-homogeneous partial differential equation, and z is given as function of x and t here, not x and y, x and t. So now conditions are not given, any condition is not given. So no matter, even in that case also we can find the solution. So dou square z by dou x dou t is equal to e raised to minus t cos x. We call this as equation 1. You can differentiate with respect to x, or with respect to t also you can differentiate. So in beginning you can choose any variable. So we are integrating with respect to x. So dou z by dou t remains on the left hand side, and e raised to minus t will be kept constant. Integral of cos x is sin x, therefore e raised to minus t sin x plus constant of integration taken as f1t. Why? Because f1t, here t is taken as, or t function is taken as constant, therefore function of t will be taken as constant of integration. With respect to t, again we are integrating with respect to t. So left hand side becomes z only, that equals, it is sin x, as it is we are writing sin x. Integral of e raised to minus t is integral of e raised to minus t dt. Integral of f1t, integral of f1t. So sin x, as it is, integral of e raised to minus t, e raised to minus t by minus 1 plus capital F of t is mentioned here. This is the symbol for integration of f1t, because this constant value is not evaluated, because initial conditions are not given. Therefore we write integral of this one as in the form of f of t plus g of x. This is called integration of this one with respect to t. So g of x is constant of integration. So then we can write this as z equals minus sin x e raised to minus t plus ft plus gx. So this will become the solution of the given non-homogeneous partial differential equation. In example, another example, solve dou square z by dou x dou y is equal to sin x sin y, for which dou z by dou y is equal to minus 2 sin y when x is equal to 0, and z is equal to 0 when y is odd multiple of pi by 2. These are the given conditions. So write the given equation as it is once again, and then integrate with respect to x. Dou z by dou y becomes sin y is constant, integral of sin x is minus cos x. So plus f1y, constant of integration. Use the given condition. One of the condition is dou z by dou y is equal to minus 2 sin y when x is equal to 0. So put here, left hand side is minus 2 sin y, and x is equal to 0. You can put x is equal to 0, cos 0 becomes 1, and f1y as it is. Then f1y becomes, whose value will be sin y minus 2 sin y, that is equal to minus sin y. So f1y value will be minus sin y. Put that f1y value into the above equation. So dou z by dou y becomes minus sin y cos x minus sin y. So this is a first order partial differential equation. Now we want to find the solution. Integrate once again with respect to y. Left hand side becomes z is equal to minus cos x integral of sin y minus integral of sin y. So cos x minus cos x as it is, integral of sin is minus cos, minus of minus cos plus f2x. This is constant of integration. So then you can rewrite this as z equals cos x into cos x plus cos y plus f2x. Now we want to find f2x value. Use the condition when z is equal to 0, y is odd multiple of pi by 2. So put y is equal to an odd multiple of pi by 2. So that is odd multiple means pi by 2 into 3, 5 like that. That is represented by 2n plus 1. So 2n plus 1 pi by 2 we have to put. So in that case z 0 left hand side it will be 0 cos x as it is and y is 2n plus 1 pi by 2 I will put. Then whose value will be 0, therefore this is 0. Again cos y value becomes 0, f2x as it is. Then finally f2x value will become 0. Put this value in the above equation. So finally z equals cos x cos y plus cos y. So this is required solution of given PDE.